This is a equilateral triangle. Each angle inside this triangle equals to 60. Let me transfer the laterals to the center. This is limit 1, am I correct?
Yes.
Transfer to the center. This is limit 3, sorry, this is limit 3. Am I right? Limit 1, limit 2, 1, 2, 6. Listen. I move from limit 1 in a clockwise manner. Limit 1 equals to 0. This is an equilateral triangle. Limit 2 would be 60. Limit 3 would be 120 because the difference would be 60 degrees. 1, 0, 2, 60, 3, 120.
I don't understand. How is it 120?
See, each in equilateral triangle, each one is equal to 60. 1 is 0. Add 60 would be 60. Add another 60, 120. What do we call this science? Trigonometry? Exactly. Trigonometry. So 1 is 0, 2 is 60, 3 is 120. This is the angle of each lead axis. 1 is 0, 2 is 60, 3 is 120. Now let us see how much would be the angle for unipolar limits. This is halfway between these ones. See? This is limit. This is limit AVL, this is AVF, and this is AVR. From the positive 0, 60 plus 30, that would be 90, AVF.
So can you repeat it? Can you repeat it?
Yes. See halfway. This is 0, 60, halfway, 60 plus 30 would be 90. Plus 30, 120. How much is it? 180. Plus 30, 210. AVR is 210. How much would be? 270. From the positive, that would be 360. AVL would be 330 from the positive direction or minus 30 from the negative direction.
Okay.
From the negative direction, that would be minus 30. This is AVL. Minus 30 or 330. And how much would be? 210 in positive direction. And how much? Minus. Am I right? Trigonometry. Each vector has a length and angle. The length is equal to the voltage. The angle is equal to the direction of depolarization. Yes. See, these are all vectors. Vectors has direction and angle.
Yes.
This is the positive end of limit 1.
Yes.
This is the negative.
Okay.
This is the positive end of AVF. This is the negative.
Yes.
This is the positive end of AVF. And if I continue the line, that would be the negative end of AVF. This is the positive end of AVR and this is the negative end of AVR.
Yes, but you
So
were-
we have two poles, negative and positive.
Yes, you were explaining that the length, what is it?
So you see the length of each vector equals to the voltage and the direction to the angle. Now you tell me the ventricle depolarization from the base to the apex. So you will have a vector which starts from the base and ends to the apex. From which direction? This is called the mean vector. This is the mean vector of depolarization of the ventricles. Mean, M-E-A-N, means average.
Average.
Mean, not the stingy. Mean is the stingy, am I right? Who cannot earn so many money. No? He is the stingy or mean, means geda in Farsi. In Arabic, what do you call mean?
لئيم.
آفرین بخیل exactement
مش مين يعني؟
اون سر کلاسه mean means stingy or بخیل بخل بخیل okay but mean here means average mean QRS vector see I will discuss it so the mean instantaneous vector quite a few foci are depolarized at the same time but you have a mean depolarization vector which starts from the base to the how much? So the length of this vector equals to the voltage difference between all these points and the direction, the angle. How much would be the angle for this mean instantaneous vector at any given time?
Sorry?
How much is the angle of this instantaneous vector at any given time?
Difference of the
60?
60. That's it. This is called a mean instantaneous vector of the ventricles. See? This is mean instantaneous vector. How much is it? 60. Or it is better to say, based on what guidance says, 59 degrees. Now, if we want to see how much, if we want to see how much of this instantaneous vector can be applied to each respective axis of each limit, you should make a perpendicular line from the apex of the vector to that respective axis. This is limit 1. If, for example, it is 2 centimeter, you should divide it by this one. Yeah, 2 times 2. That would be the
Maybe
length
this-
of this one.
Pythagoras theorem for this.
You see, this one, you should measure this part divided by the whole and times the length of this one. That would be the length of this. This is trigonometry.
No, can you repeat it? I don't understand.
You see, how much is, for example, this is 2 centimeter.
Okay.
And this is 1 centimeter. This is C, B, A. C2 equals to B2 plus A2. Am I right?
Yeah. That's it. Okay.
Am I right? See? 2 to the power of 2 equals to 1 to the power of 2 plus B2. And then from here, you can take it out.
This is Pythagoras theorem.
Pardon?
Pythagoras theorem.
Exactly. What do you call it?
Pythagoras theorem.
In Farsi, what do we call it? مثلث فیثاغورس. Exactly. In Arabic, Pythagoras. Is that clear? So in order to see how much of this vector can be seen, for example, in limit 3, take a look. This is limit 3. Am I right? From this mean vector, you should make a perpendicular line Am I right? And that would be what you can see in limit 3. For AVF, see, this is AVF. Am I right? Make a perpendicular line to AVF. That is why in each electrocardiographic lead, you may have different sites of QRS complex. One big, one shorter. Did you get? In electrocardiography, if you have an electrocardiography trace, you can see that. For example, in limit 1, you have a small QRS. The big QRS that you can see is in limit 2. From V1 up to V6, the big QRS complex that you can see is in V3, V4. From V4 and V5, big QRS complex that you can see is in V3, V4. From V4 and V5, the length of the QRS complex would be gradually shorter. In limit 2, you have the biggest QRS complex, biggest positive QRS complex in normal healthy people.
In limit 2.
In limit 2. Why? Because the exact mean QRS is around 59, which is totally correspondent with the angle of limit 2. So this is the vector and resultant vector. See, this is the vector, this is the resultant vector. Bordare, in Farsi we call it bordar. What do you call it in Arabic vector?
اتجاهية
Murtaje?
اتجاه
Sure. Are you sure? Bordar, check it. In Farsi we call it bordar. Bord means line. Aleph and Re at the end of bordar makes it an adjective in Farsi. Like, no, make it a noun. Like raftar, like gireftar. Gireftar is adjective, but raftar is a gerund. Bordar. Make it a noun. See? In Arabic, find what you call it. A vector. So these are trigonometry. Now, you have learned that the mean QRS vector is 60 degree. In some situation, this mean vector would be shifted to the right or to the left.
How can it be shifted?
I will discuss.
due to the positive and negative sign.
Now, suppose that somebody is suffering from aortic valve stenosis or hypertension. Suppose that somebody is suffering from aortic valve stenosis. If there is aortic valve stenosis or hypertension, your left ventricle is actually make a pressure to overcome the pressure in the aorta, and gradually the wall of the left ventricle will be thickened. This is called hypertrophy. What do you call it in Arabic? تضخم. Exactly. I'm زخیم to فارسی ما میگیم. تضخم. تضخم. Don't? Are you sure? That is why I cannot learn Arabic. تضخم. وخیم میگین شما؟ وخیم؟ تضخم؟ تضخیم is something else. تضخیم. Okay, now. See, if you have left ventricular hypertrophy, then this mean QRS vector would be shifted to the hypertrophied ventricle. Instead of 60, you will have 30, 0, minus 30. This is called left axis deviation. Did you get?
No, sir.
Yes. You see, suppose that you are recording electrocardiography from a hypertensive or aortic valve stenotic patient. In left ventricular hypertrophy, high ventricular mass can be found in the left ventricle. So when you have higher mass, you have higher depolarization. So the mean QRS will be shifted to the hypertrophied ventricle. The mean QRS axis is 60. When it is shifted to the left, that could be less than 60. For example, 30, 0, minus 30, up to the normal QRS, I mean the normal cardiac axis. Mean cardiac axis is 60. There is a range for that. Between minus 30 up to 110 is normal. So if it is less than minus 30, this is called left axis deviation. That can be seen in left ventricular hypertrophy, in aortic stenosis, or in hypertensive cases. Suppose that right ventricle is hypertrophied. You have pulmonic valve stenosis. There is a disease, a syndrome, a congenital syndrome in the heart, which is called fallotetralogy. Fallow, a Frenchman. This is not called fallot. Fallotetralogy. Tetra means four. Four signs together makes fallotetralogy. Overdriving of aorta and right pulmonary artery. Aorta, instead of leaving the left ventricle, is originating from right ventricle. Pulmonary artery is coming from the left ventricle. They are exposed to each other. There is ventricular septal defect. Between those two ventricles, there is an opening. This is called VSD, ventricular septal defect. Exposition of aorta and pulmonary artery. Ventricular septal defect. Pulmonary stenosis, this is the third one. And atrial septal defect. This is called tetralogy of Fallot. In tetralogy of Fallot, since the opening of the pulmonary artery is very narrow, you have hypertrophied left ventricle. So this mean QRS vector will be shifted to the right. Instead of, for example, up to 110, you have 120, 180. Left axis deviation.